Good morning, everybody.
Good morning.
Okay, so let us start our lecture today. And today is September 7th, right? So we are in week 4. So, okay, before I start, there are a few announcements. So, as this lecture is going to be for both section 2 and section 3. I know you're in section 3, but I have another section that students are online. They follow this lecture. So this announcement is both for section 2 and section 3. Okay, one thing is that I updated the syllabus. Actually, I have some misunderstanding. Actually, the course is running parallelly with other sections, so I have to go with them. So the update that I have to do, I updated the syllabus with newer version. So in section 2, you will see syllabus version 3, but in section 3, you will see syllabus version 4. So whatever you in your section, please read the syllabus, get the syllabus, and the major changes. One thing is that the number of assignments. I thought initially I would make my own assignments for my section, and I would combine 2 or 3 weeks for assignment, but I was supposed to follow the other sections. They are going parallelly. So there will be about 10 assignments. Okay, the first assignment is passed. So 39 people submitted their assignments, and our grader will grade it. Okay, the second assignment that will be due on September 10th. Okay, the regular due in September 10th, and I will extend it 2 or 3 more days with 10% penalty per each day. Yes, but the second assignment, so it is already up in your in the 12. Okay.
So wait, the second assignment will be due in 3 days?
Yeah. So in September 10, I will make it in the weekend. So I will make it in the weekend. So let me make it until the weekend.
So basically Sunday normal as the last one.
Yeah, but the last one is normal on Sunday. 12. 12. Okay, it's 12. Okay, for this is section 2, and you're in your section. Okay. So if you go to the syllabus, so I have adjusted the syllabus number and date according to the D12. So this is the assignment 2. The assignment 2 will be on pointer and the dynamic array that we will discuss this week. Okay. So now let us start. So then there will be about 10 assignments. There are 9 assignments so far. I will see maybe 9 or 10 assignments. Okay. Now, if we go to the course content, this week, pointer and dynamic array, chapter 4. So this is our lecture slides, and this is our, there's some sample programs. Okay, and this is the assignment. Okay. Let's go on by one. So this is a book, chapter 4. So chapter 4 is about pointer and dynamic arrays. So pointer is a new concept in a very limited programming languages like in C++. In C++ and C languages, we use the pointer. Pointer is a concept, but modern languages like Java, C#, Python, these languages have not included pointer because handling pointer is tedious and time consuming and a kind of nightmare for many students. So it is something difficult for understanding and handling pointers. So modern languages have got rid of pointer. So now let us discuss how easy or different way I can present pointer to. So you need to read this chapter. Okay, so in order to understand pointer and your quizzes and your assignments, you need to read the chapters. Okay, so as usual, so our slides have main points that we will discuss. So if you understand, remember the main points, then it will be easy for you to understand other things. Okay. So as we know in our previous courses, or previous chapters, we discuss array, right? In general, by saying an array, it means a static array. There are some limitations, advantages and disadvantages of array, static array. One thing is that static array is faster, that is the advantage, and it's an easy data structure, but there is a problem is that while declaring a static array, you have to fix the size, array size. You have to put its array size. So the compiler put the fixed amount of time for the array size, and then while you are running a program, you cannot change the array size. Okay, so then there is a limitation that in case you assign a small array, an array with like 10 elements, but you got 12, 13, 14, or 15, 20, or 100 elements, so you cannot change the array size. So for instance, if you have used, or if you know that someone used like old, not non-smartphone, like older phone, like the mobile phones that were about 20 years ago, like the Nokia or non-smartphone cell phones. Those kind of phones have limited memory spaces, limited spaces to save your friends and family number, contact numbers. So a long time ago, I used a phone that has limited only 255 contact number, it could say. Actually, that phone, that data structure that phone used with static array, because at the end user, we get only the executable version of our program, right? We do not get source code, so we cannot change it. And even it is source code is given, many people, they cannot change it, right? They don't know how to program. They cannot do it. So the programmer, when they develop an app, is a program or software, an app, they give executable version to the end user. So end user cannot change the size, memory size. Even it is easy for programmer. So there is a limitation that an array size cannot be changed. Okay. On the other hand, so if you declare a very large array, but if you have very few limited number of data element, so then there is a scope of misusing your memory space. Okay. So in order to resolve that kind of issues, so a new concept of array, it is called dynamic array, is used. Maybe some of you are familiar with dynamic array, like array list, okay, or linked list, stack queue. So this kind of dynamic memory allocation, this kind of data structure, these data structures use dynamic memory allocation. Dynamic memory allocation means that the program, while running a program, it allocates its memory. Okay, so as many data element you have, there is no possibility of shortage of data of memory, or there is no possibility of memory misuse. So that is the main advantage of dynamic arrays. So we will see that how dynamic arrays are actually declared, are created using pointer. Actually, pointer in C++, pointer is used to declare dynamic array, to create a dynamic array. So the main part, there are multiple purposes of using pointer. First of all, actually the main goal is to declare dynamic array. But the other simple purpose is that the pointer actually, let us understand what is a pointer. A pointer is a value of the memory location of a variable. For instance, what do you mean by this? Whenever we declare a variable in our program, so we say int I or int j, right? So it takes a memory location. Every variable takes a memory location. For instance, this is the this 4 location integer type text, 4 memory byte consecutive memory bytes, this integer type variable text, and we do not know at what position in our computer memory this variable text location. So the pointer can be used to retrieve this memory location. So if it takes 4 bytes, then it will starting byte will be starting address. Maybe let us consider that each of this address 990. This is hexadecimal format. Okay, 990. It is the starting address of I. So then the 4 byte will be, and each of these indicates 1 byte memory. So 1, 2, 3, 4 bytes. Okay, and then 990, 991 to 993. This will be consecutive 4 bytes. But this will be for allocated for I. This is the memory locations for I, variable I. But in our regular program, small program, we do not know where this memory, where this variable takes in memory, take position in memory. It is not our headache for regular program, but it is possible. You may have that. It is possible that we can find the location address of every variable is declared in computer program. So how that is possible? That is used That is possible by using another type of variable that is called pointer variable. Actually, pointer variable is used to hold memory address, not the actual data. Pointer variable holds address, memory address. These are the memory address in hexadecimal format. Okay. Similarly, if we declare another integer variable j, so they will take another position. We don't know what is position. For instance, let's assume that position will be starting from 994. So 994 to 997, these are 4 consecutive memory locations. Okay. So what is a pointer? A pointer is a value of a memory location. So this value we don't know the value of I yet. Okay, so if we assign I equal to 10, that 10 will be placed in this memory location. But address, even if we put a value or do not put a value, still this variable will take a memory location, right? It will take place in memory. So this is the address. So every variable has its address in memory, its location. So that is retrieved or accessed by a pointer variable. Okay. So to declare a pointer variable, there is a different way. It's a little bit different way to declare a variable. We just use an asterisk sign. Okay. So then it's a double. So for instance, asterisk star my first pointer. So it is my first pointer. This is an identifier, so any name you can give, but in generally we give a good name, so we use underscore pointer ptr. That means we remember that this is a pointer variable. So what is the pointer variable? The pointer variable is a variable that holds the memory address of a variable. It does not hold the actual traditional data. Okay. Now, so the name is an identifier name. So any good name you should be given. You should follow the identifier name. Okay. It should be an unique name. It should be a unique name in the program. And asterisk, this star means this is the pointer. Okay. This variable is a pointer variable. And double, what is the data type means? Data type means the pointer variable is not double. Key point there, this double means this pointer variable will hold an address of a double type variable. Okay, this double means the type of the data that the pointer variable can point to. That means if this variable, this pointer variable, it can point a double type variable. So we know that a double type takes 8 consecutive bytes, right? And then an integer type takes 4 consecutive bytes. So the type is important. Okay, so if you declare a pointer with double type, okay, that means that then it cannot hold an address of an integer type. Okay, so we should give a good name. Okay, then we should be aware of the type, but what kind of variable this pointer variable will point. So we can declare multiple pointer variables, okay, by this fashion character. This is the star. This is used for every pointer variable. Okay, so this is minor difference. So if you do not use star, then it's a normal variable, and if you use a star, that is the pointer variable. So at this point, do you have any question to understand what is a pointer?
Yeah.
You understand, right? Okay. So pointer is unique in C++, for instance, and our language. So if you know Java and C#, you are not familiar with a pointer. Okay. But don't worry, it is not that much difficult if you understand the main concept. So okay, so how do we know that? What is the pointer variable? The pointer variable is a variable that stored address of a memory location. A pointer variable does not hold or store value of a value. Okay, it does not hold value. It holds address. Okay. Okay. So these are some examples. How do we? So this is this first line. It is familiar with, right? So it is I integer variable I. It is assigned with value 50. Then 50 will go to I location. And with the int star IPTR, there is I underscore PTR. This is a pointer variable, and it can hold any pointer, any integer type variable's address. So at this point, we have not assigned. We have not assigned which variable's address it will hold. So this is the line we are assigning. So this line we are assigning that here IPTR equal to ampersand I. This ampersand means it holds, it retrieves the value at location I. Okay, so the ampersand is an operator in C++. It is used, okay, it is used to find the content, okay, or actually find the address. It's find the address of this location. Is find the address of this variable. So ampersand I is used to find address. So then, so this line we are assigning that IPTR will hold the address of I. Okay. Now if we print out cout I, then it will print 50. Right? And then now if we print, you see that star PTR, that means it will hold the content of that address. So give me 1 second. Let me get my pen and okay. So this line, okay, I'll focus. I want to focus this line. So how do we get with 50? So actually, the rule is that So that means we need to let us put this and C out star, okay, and then IPTR. What is I underscore PTR? I underscore PTR equal to star. You see that I underscore PTR equal to ampersand I. Ampersand I. That means this star and ampersand I, this will cross out. You can easily remember that this will be cross out. So that's actually that I. So in other words, we can say that print the content of memory location. Print the content of memory location I. Okay, whatever value at the memory location I has, get that value. That means ultimately it will get the value I. Okay, that the value of I. So this line and this line, they are identical. They will give same result. So this is just telling I, print I, and printing star asterisk I. So this one. So this is not a pointer variable. So there, that means we know that a pointer variable it holds an address, right? Okay, but I like you to do another example. So if you do C out, like if you say only IPTR underscore PTR, okay, so then it will print address, the memory location, something like this. Okay, but when you print star I underscore PTR, then it will be printing the content of that memory location. Okay, and similarly this statement you can use pointer variable. So here the pointer star pointer, so that means star IPTR equal to 100. That means at that location, what it says, that star IPTR, that means underscore, this is actually, this is I. This is I equal to 100. That means you are changing I. So that at this case, I will print it 100, and then this address, this again star I underscore PTR, it will be printed 100. Okay, so this is a tricky thing. So if you understand this, then you will easily understand or work with pointer. So has anyone any question? Do you have any question about this
Now,
few lines?
I just wanted to clarify
Okay.
that that's also considered dereferencing, correct?
Yes. Yes, you can say dereferencing. That this one, this statement, you can say dereferencing. Dereferencing. You can say dereferencing. Okay. You will understand this? Okay. So if we go to a small program, mistake. Okay. I usually write standard in spaces 2D. Okay. So I say int I equal to 50, and then int star, so I underscore ptr. Okay, and I have not assigned it. I can say that equal to ampersand of I. This I equal to okay, it's gone. So now if I print I, then it is printing 50, right? So now if I print the pointer, okay, and then let us see this now. So this is the memory location. We don't know yet. Okay, this is a large memory location. This is hexadecimal format. Okay, so the book has only the last. It is denoting the last. For easy discussion, denoting the last 4 digits. So maybe the last 4 digit is 1BCC. In the book they have 9990, or last 3 digits. Okay, last 3 digits BCC. So if you run this program in your computer, you will get a different address because you don't know at which place this variable is taking place, at which memory location. So now if I print this one, okay, star of I, okay, and then star of I, then what will be printing? It will be printing I value, right? It's printing 50. Now if we change, as we said that, other way, that if we say other way, if you declare, if you change I equal to maybe 100 instead of this, okay, then it will be getting your new I value, but the pointer value variable that has the same address, because the address has not changed, because we have only one, we are dealing with one variable, right? The variable is its own location. The variables is same. Now you see that this time I got a new address for this variable. Okay. Similarly, what I can do, I can say content of I equal to 200. Now if I print I, that is 3. The same thing, it will happen. Okay. It will get I equal to 200, and it is getting same memory location, and it's get I pointer, star I pointer equal to 200. Okay, so this is the program I want to give you. So please start practicing from this program. Okay, do you have any question? Do you have any question about this program?
No.
Okay, so that's all. If you understand this, only one program. If you understand this, then I think we're done most of the slides. Most of the slides that we have in this lecture, that all of this are the gist that I discussed with the program. Okay, now you can quickly go through these slides. Okay, go through these slides, and then you see that you can use multiple pointer variable. Like in a program, you can use multiple variables, right? So you can similarly you can use multiple pointer variable. So this is the program. So you please practice this one. You see that when copying memory address, okay, then when you contain the memory address from, when you copy the memory address, content of a memory address from one pointer to another pointer, the value will be changed. So this is the program. I like you to practice this program yourself, okay? So please practice this program, okay? And again, so when you run this program, you may not get this kind of result. So this is a symbolic, some kind of hexadecimal value you will get from your program. Okay, so everybody please practice this program, okay? And if you do not understand this, then I will discuss this in our next lecture. But if you give attention in my previous program, and then this thing is easy, okay?
Professor, I think you might be muted.
Okay, I don't know how did they get muted. Okay, so this one I asked you to practice these two programs. So that this one, and the next one. So this program, just if you give attention to my previous program that I discussed here, so then you should be able to do this. So this is copying a memory address value. For instance, let me give you an anecdotal example. For instance, if you leave, so a memory address contain only one value, right, at a time. There is no way that a memory address will contain two or more values. Only one value. It will contain only one value, and that is the updated value. For instance, you live in a house, okay, or a room number. For instance, room number 101, 102, 103, something like this, and you are the only person living in this room. So if I ask someone, okay, go there in room number 101 and ask the person who is living over there. Okay, then you are the only person living over there. For instance, your name is John. So then if someone goes to your room 101, then he will get you, right? He will get John. In other way, if there is only one John in the entire building, and then if I ask someone, okay, call John, so then he will get you, only you, because there is only one John in your program, because we know that in our program we cannot have multiple variables in the same name, right? Only one variable All variables will have unique name, right? If they are group of variables like an array, then they will be named by index. They will be different by index. So this is the way that there are two ways to get the content, for instance, of a memory location like a room number, by calling the person who lives over there. That is the variable who resides over there, the variable name, or by getting the content of that location or that room. If I ask you that go to the room number 1 and get the person who is living there, since there is only one person who will be living there, so then the right person will come in. And since there is no way to have duplicate names in an entire program, so then there will not be any conflict. Okay, so I asked you to practice these two programs. Okay, like here this line is different. So copying content of one memory location to another memory location. This is like copying value from one variable to another variable. Same thing, something like this. Okay, so please practice these two programs. Okay. So like if you do that, then you will then come to the practice this program, and then you understand this. So pointer variable sometimes is used with like this assignment operators. Assignment operator is used to assign the value from the right to left, right? The value of the right side variable is assigned to the left side variable. So similarly, is pointer, this one is says that the value at the content of this p location, p1 is a pointer variable, goes to at memory location p2. That means ultimately the same value will be changed, right? That means a copy. This will be a copy, a duplicate, making p1 value to p2 value. That means p1 and p2 will contain same value. Okay, sometime, for instance, in our program here, whenever we declare a variable, pointer variable, we assign it, we pointed it to the a location. But sometimes if we do not do it, just if we do not do it, right? So this, in this program, what it will say that it will say that just iPointer is a pointing variable, is a pointer variable, and it will be able to point an integer type variable. But we have not said what is that variable. If I have another variable int j equal to 1000, or even if I do not have j, so it does not mean, the name does not mean that it will point to I, because I have not used that one, right? I got rid of this. If I do this, then it will point to I. Okay, that means it will point to I. So until I do this, then the pointer will contain is null value. So it's a null value. It's initialized with null. Okay. So here, if I'm gonna run this program, you see that it is showing an error. The problem is that when I declare this pointer, I have not assigned this value, or at least if I do not assign that, I need to put null. Okay. Then if I put in null, then this and assign it to integer from compatible install. Oh, sorry. That was not better. Why did not work? Let's see, it should work. Oh, in percentile. Okay. So here it is defined initializing, okay, with null. And if we initialize with null, then we cannot have any content. We cannot, this line will make an error. But later, if we initialize it, then it should work. Why it is not working? Oh, I did a mistake over here. So this time, this one, I already declared this one, and it should be this one. Okay, so this is non-initialization, and later, so actually this point, the star is a part of type. Okay, it is not part of this. Okay, so now it should work. This is non-initialization, and this is initialization assigning. Okay, so this is the slide about. Okay, now in order to okay, now in this chapter our goal is dynamic array. So in order to declare a dynamic array, so we use pointer. It's a pointer. Okay, so in C++, there is a new operator. There is a called operator new, new, all in lowercase, that is used to declare dynamic array. Okay, for instance, dynamic variable and new operator. So the actual use of pointer variable is to initialize memory location dynamically through dynamic variables. Okay, so dynamic variable is not declared in the code. It is created during the runtime using new operator. For instance, here, let us understand. Now everybody is familiar with this, right? Okay, initially if his pointer is not pointing to anything, then it is null pointer. Okay, this is a null pointer, this is coming, and then for, okay, let me in the program. So even if we do not do this, if we do not use null, then by default it is null pointer. So then we can do this. So by default it is null. Okay, it is not assigned to yet, but explicitly you can put null. Okay, now this is the null pointer. Grade PTR is a null pointer. Now if I say grade pointer equal to new int, that is allocate memory space pointed to add by grade pointer with an integer type. So that means this grade pointer will hold the address of an integer type variable. Okay. Now, if I say content, star means content of grade underscore PTR equal to 90. That means what I'm doing over here, this one is actually the variable, integer type variable is 90. Okay, and I am holding, I'm assigning the value of that integer type variable to 90. Okay, so these two statements can be written, these three statements actually, these three statements can be written together in one line. Int grade pointer equal to new int 90. Okay, there is a constructor over here. So for integer type declaration, there is a, this is a constructor, int constructor, it is being used over here. Okay, and that 90 is the for integer type variable, and star grade underscore PTR, it is holding the value, okay, of where this 90 is located, the content of that memory location. Okay, sometime so please try to understand these three lines. Okay, write a program and then you will understand this. So actually this is these three lines, sometimes you will see that these three lines are written in one line like this, so it is sometimes confusing. Okay, so if you break down these three lines instead of this, then you will understand how it's going. Okay, so initially when you declare a variable, pointer variable grade PTR, that will take null value, and then whenever you say grade PTR equal to new int, that means it will assign to an integer memory location. This is maybe 4 byte. We have not assigned that value yet. So now if I see the content of this memory location will be 90, so the 90 will go here. Okay, now so in order to declare a dynamic array, so as our goal to understand dynamic array, so we use a little bit, you see the notation is a little bit different. New int, this is square bracket. Square bracket is used for array, right? Square bracket is used for array, and this one, so that if you go the previous example, you see that this is not square bracket, this is parenthesis. Okay, this is used for function call, but that one is array declaration. So this is dynamic array declaration. So be careful about the square bracket and parenthesis, use of parenthesis. Be familiar with this. Okay, this is parenthesis and this is square bracket. Okay, so that means here is grades are pointers, null pointers, and then we say grade equal to new int 20. That means you are declaring a dynamic array of integer type, okay, with size 20. Okay, so following the example of previous page, like this page. Okay, I'm sorry, this page, following the example of this page. There is a way to write those two lines, something like simple signal like this, simple like this. Okay, so there's two lines. Now tell me, can anyone please tell me how can I combine these two lines?
Yeah, sure, I can do it.
Yes, tell me.
All you basically need to do is write int asterisk grades equals new int square brackets 20, size 20 for the array.
Yes, what that mean? What does that mean? So you said, let me write it down. You said int star grades equal to new int, right?
Yeah, I think that's it.
Yes, that is correct. Yes, this is the combination of these two statements. I'm sorry, so okay, this is the combination of these two statements. Okay, can be written as this. Okay, so now that is a new array. So dynamic array. So this is handled by pointer. So this pointer will indicate that it's a dynamic array, and size, initial size will be 20. Yeah, and then you can change this size as long as you dynamic array will see that, and there will be some built-in dynamic array it will be. But for now, so let us find the difference between an array and a dynamic array. So this is the array pointer symbol is important, right?
Yes, very.
Okay. If you forget this pointer, and then it will not work. So you missed it. Okay, one thing is that this array will contain only what kind of data?
Only integers.
Only integer, and it, by the way, it can hold integer type, because integer type has what is that called? Byte and short together, right? Byte and short together. So right, so byte is 1 byte. Byte. So this is data type byte. 1 byte, right? And then this is short, 2 bytes, right? And int is, I'm sorry, actually I can write this way. I can draw this way. If there are 4 bytes memory, so this is lowest. Okay, the right side is the lowest, right? So this is byte, 1 byte, and this 2 is short, and then whole thing is int. So integer, within integer you can hold a byte type or short type or int type, right? For instance, the number 10, it falls, it can be a byte type, it is within a range of byte type, it is within a range of short type, and it is on integer type. So it can hold integer type. So by default it is integer type, but it can hold a value that is there also fall in byte type, and that is short type. You understand what I want to mean here? So there are 8 primitive types, right? Data types, right? Byte, short, and int. So byte equal takes 1 byte, 1 memory byte, small data that takes one memory byte, and then short 2 memory bytes, 2 bytes, and then integer 4 bytes. Okay. But this one, so there is a difference here. Actually, here this one is double type, right? This one, last one. It will create a dynamic array of size 7 that will hold what kind of value? Double. Do you have any question? Does anybody has any question?
No questions for me.
Okay, thank you.
No questions.
Okay, thank you. So now let us see if you go to this slide. Then this slide is so int star p1. That is p1 at this point. P1 is declared, but it has not assigned to point to anything, right? So this is null pointer. Initially, it could be a null pointer. Now create an array of size 4. Then you say p1 equal to new int 4. Again, I like you to give attention here on this symbol, square bracket. The square bracket is used for array. Okay, don't mislead it with the previous parentheses. And then on the previous slide, it was used parentheses. Okay, parentheses is to assign for a single value, and this is for an array. And now, if we assign 42 to the index 2, so this will be a dynamic array. Array will start with index 0. The third element, right? 42, that will be third element. So then first element has index 0, second element has index 1, third one index 2, fourth one index 4, 3. So that's the third element in the array will be 42. This is assigned with index 2 is the third element. Be careful about this one. Third element in the array. Okay. So dynamic array, actually array is allocated in heap, that is free space in computer memory. Okay, and then whenever an array dynamic array is allocated, if it is no longer needed, then we can use delete. There is a delete keyword. New keyword is used to assign memory space, and delete keyword is used to delete memory space, unassign or release the memory space. Okay, sometime in a short program we will not use delete, but it is a good habit if you be familiar with delete, because for a large program, okay, that if you handle, sometime I worked in a company for a few months that they work on auto insurance. So they have their C++ program, like a class file. There is 70,000 lines of code, 70,000 lines of code in each file. Okay, so then we at some point we got issue that the program did not use delete, did not release the memory space. So sometimes the program terminated unexpectedly. So we work sometime to include delete operator to release the memory space. So this is how just delete is used. So delete grade. That means this, whenever it is done after the operation, then it will be deleted, the memory space. But for the short program we are dealing with in our practice, we do not need to delete, because we have huge amount of memory space. But it is a good practice, good habit if you know how to use delete to release some memory space. And you can practice that. If you use delete, then you no longer can use the probes. For instance, here, if I say so delete this one. Did you see the error? So I deleted this one, so I cannot no longer have access to this line, this line. Okay, so if I do not have this line, then it is fine. Program will work. Still I is working. Let me for now get rid of this. And it is working. How? What is that? Let me reload it. Aborted code dump. Do we need free? I must, there is something missing. Okay, so you can give your own name, declare name of your pointer type by using typedef command. So by giving a custom name of your typedef. So by using typedef, you can use. That means typedef is used to give a new name or custom name of an existing type. Okay. So now what I want to do, so there is two things is parameter passing. We know that when we call a variable, when we call a function, we use parameter to assign value, to pass value to the function. There are two ways. It is called pass by value and pass by reference. So Java uses only pass by value. Okay, C++ and C#, these languages use both pass by value and pass by references. So through passing value through pass by references, we can a caller function, a caller function, that means a guest function. A call function can change the value of the host function. Okay, maybe I have a few more minutes left, but I need some extra time to discuss this. We'll discuss this in our next lecture. But let me give an example, anecdotal example. How many of you can hear me? Please raise your voice, okay? Okay. Okay. Let me give an example. Okay, thank you. So for instance, if you invite someone, if you invite a guest to your home for a lunch or a dinner, okay, and do you like your guest to make some changes in your house? If your guest tell me, oh, hey, you should have a window here, you should have a door here in this room, do you like that guest to do you like your guest to do that, to make that changes or to make that comment? Sometimes no, right? Usually no. Okay, that you don't like that your guest will make any change at your in your program structure or in your house structure, like your program structure, right? So this is called call by value. That means if you do not allow your friend to make any change in your program, or if you call a function within that, the function will be called, but the function will not change any value in the caller function. That is called call by value. And there is another way that is called call by reference. Call by reference, if you can remember an example, that if you allow your guest to make any change in your house. For instance, if you invite a guest and your guest comes in your home and you see that, hey, you see that there is no window in your room on the on side, and he just, maybe he has a magic power or she has magic power, and she makes the changes quickly. She put a window in your room. If you may not allow this, but in some cases you may allow it, right? If your guest is something valuable to you, right? If he or she tells you, hey, I'm not gonna marry you until you have a window at this place of your room, right? So in that case, you may consider that, so that if you allow your guest to do that, then that is called call by reference. So through call by reference, what does a guest or call function can do? It can change host property, host value. Okay, but call by value, in a call by value method, it is not allowed. So okay, so this is why call by value or call by reference. So in our next program, I will give you, in the next lecture, I will give an example so that you understand this. But for now, please remember this anecdotal story. And but it's sometime if we never want to allow these changes, then we see that we use that is a constant. We use a constant keyword in the parameter, so that the host or guest can never do that change or never think about that change. Okay. So this is maybe in our on program, previous program, we use constant keyword in last week. So I will go through this in our next lecture, but we have a few more slides left. So I like you see that there are few programs in these modules. Please download these programs and practice this. Okay, so there are a few programs in these modules. Okay, before we come to our next lecture, please download these programs. Okay, and try to understand this. As much as you understand, then fine. I will go through and complete this in our next lecture. Okay, that's all for now. Has anyone do you have any question? Does anyone any?
Yeah,
Yes.
I had a quick question. I think you mentioned it at the start of the lecture, but for assignment 2, you said you're going to change the due date to Sunday instead of Friday.
Yes.
Okay,
but
thank you.
For this one, I changed to Sunday. For this one, but maybe I need to in the future assignments, I need to adjust with other sections, because for this for the other section have 10th. Okay, so but for the September one, I will make it September 24th. Okay, as is. So for this one, for assignment 2, I changed this to September 12th.
Okay, thank you.
Thank you so much. And let me get the.
Thank you.
Okay, so let me get the attendance today. And thank you so much, and I will see you day after tomorrow. Bye.
Thank you.